Okay, if this is a 0, it's an imaginary number, but if it's a 0, then it means x minus, and I'm going to use a parentheses, x minus that imaginary number must be a factor, because look, if you were to plug in 1 plus 3i in for x, then you'd have 1 plus 3i minus 1 plus 3i, and that would make 0, right? Okay, so this needs to be a factor of this function. So f of x, we can rewrite it with its first linear factorization like this. It's x minus 1 minus 3i, and then we need to use division to figure out what goes on over here. Okay. So look, remember, this is I didn't come up with this out of thin air. It's because if I plug in 1 plus 3i in for x, it would make this be 0, and 0 will distribute to whatever we're going to find in this parentheses. All right, so to find out what goes in that parentheses, we got to use synthetic division. So the root of the divisor always goes up here when we use synthetic division. Okay, or you could use long division. You're dividing this by this term with long division. But the root of the divisor always goes up here, and then you write down the coefficients. Remember what the root of the divisor means. That's the thing that would make the divisor equal 0. I don't need a positive sign there, sorry. So 1 plus 3i would make this equal 0. Okay, and then we carry down the 1, and then we start conducting our synthetic division. But this is going to take a while because we're going to have an I term in here as well. 1 plus 3i times 1 makes 1 plus 3i. And it's just like combining like terms, only when you add these, the negative 2 plus 1 makes negative 1. And then we add the 3i. So we're carrying over an imaginary number. And then you repeat the process. This needs to multiply to this, and the result goes here. But we probably can't do this in our head. Let's write it off to the side. 1 plus 3i times negative 1 plus 3i. I'm multiplying this term times this term. And if I do that, I get negative 1 plus 3i minus 3i plus 9i squared. So it's negative 1. Those cancel out. And I squared is negative 1, so this is a negative 9 term. So it actually turned out to be a real number. I'm sure the textbook set it up that way. It's going to be a minus 10 here. Then we add the columns. Then repeat the process. This times this goes here, and then we add the columns. So negative 5 times 1 plus 3i, that's going to be negative 5 minus 15i. And just like always with synthetic division, we add the columns. But 10 plus negative 5 minus 15i, the 10 plus negative 5 makes 5, and then minus 15i over here. And then we got to do it one last time. We got to multiply this times this and add them up here. Now remember, this is supposed to be a factor. They told us it's a 0. So if we've done all this right, by some sort of weird black magic, this times this needs to equal positive 50 so that we have no remainder. Okay? But let's find out if that happens. This times this, that's 1 plus 3i times 5 minus 15i. And so when we multiply that using FOIL or whatever method you're used to, 1 times 5 is 5, 1 times negative 15i is negative 15i, 3i times 5i, oh, that makes 15i, so those are going to cancel. Oh my gosh, 3i times negative 15i makes negative 45i squared. It's happening because this cancels out. I squared is negative 1. Negative 45 times negative 1 is positive 45. 5 plus 45 makes 50. Whoa. Whoa. Then you can add the columns. No remainder. All right, so all that work, and we just found out what's left over after you divide this by this. Remember, it descends. The power descends by 1, so x to the 4th now becomes 1x to the 3rd plus, and then this entire negative 1 plus 3i is the coefficient of the x squared term. And then this minus 5 is the coefficient of x, and then this is the term hanging out by itself. Okay, now I know that was a lot of fun. A lot of people watching this video would be sad if it's over, but it's not over, okay? Because we're supposed to break it down into linear factors. This is a linear factor because it's x to the 1st power, but this is not. This is x to the 3rd, so we got to divide something else. So look, if 1 plus 3i is a 0, we actually get a little extra information. It's that by 1 get the second one free deal. Buy one, get one free. Yeah, there we go. Buy one, get one free. It's 1 minus 3i must also be a 0. If this is a 0, then this is also going to be a 0. So we know what to factor out next. Okay, we're going to rewrite this as x minus 1 minus 3i. That's one of the factors. And then the next one is going to be x minus 1. Here, I'll put it in parentheses again. 1 minus 3i, which is different, right? Because the sign is going to be different on the imaginary part. And we need to figure out what goes here. So we got to conduct synthetic division again. This is the linear factor, so we're taking this, we're dividing it by this. So the root of the divisors, the thing that would make it equal 0, that's 1 minus 3i. That goes up here. And then we write down, sorry, I deleted this on accident when I was pausing this crazy video. Okay, now remember, we're not taking these terms though, because we've already broken it down into smaller bite-sized pieces. This is what we're dividing. The 1x to the third, and then we have negative 1 plus 3i for a coefficient of x squared, and then a negative 5 for the next term, and then 5 minus 15i is the no x term. And then synthetic division. Carry down the 1. So 1 minus 3i times 1 makes 1 minus 3i, and then we add the columns. Look, negative 1 plus 1 makes 0. 3i plus negative 3i, that makes 0. Oh, the book had so much mercy on us with this problem. And then you repeat the process. This times 0 makes 0. Add the columns. This times negative 5 makes negative 5 plus 15i. Add the columns. That cancels, that cancels. It gives us 0 for remainder, just like we'd expect. So this is x to the third originally. We divide it by a linear factor, so it's brought the power down to 1x squared. You could write plus 0x if you want, and then minus 5. We're so close to being done, okay? So this is what we've broken it down. I think it said what it say. It says linear and quadratic factors, so we're done here. I find it as a linear factorization by miss some instructions. We could factor this with square roots, but this is where we can stop because this is a linear factor. It's x to the first power. This is linear, and this is quadratic. So we just found out that this can be rewritten as this. How exciting is that?